Those of you that have never heard me speak before, I tend not to do a very good job of staying on subject. I'm supposed to talk about aerodynamics, but I have to break for a second. Why is everybody here? We're throwing a ton of information at you, number one. Let's talk about that. I know from at least the way that I learned and through all the engineering classes I sat through, that it doesn't always make a whole heck of a lot of sense when all of this is coming at you at once. I mean, it's hard enough to stay awake during this part of the time, and it's not because you think that the presenters are uninteresting or things like that. It's just because there's a lot of material in here to absorb. So why do this? Well, we've got the recordings of this that'll be up there. We've got the PowerPoint slides. I get that if you've never been exposed to this before, it may not make that much sense. But I promise you, when you get to that point of the program where you're having to build something, where you're making these trades on how you want your car to be, go back and re-watch that section of the workshop, just that section, and what they talked about. I guarantee it will be a help to you. When you start building your solar car and you're trying to figure out what to do, or after you're a little ways into it, and you want to take a mental break for a little bit, but you're not ready to give up on solar car, go re-watch one of those sections. There may actually be a tip in there that solves one of the problems you have. And heaven forbid, before you come to scrutineering, maybe ask one of your team members to scan through the workshop and pick up all the times when we said, hint, hint, this is how you get through scrutineering. Just a heads up on that, because I know it's a lot, and it would be a lot for me never having done this before. But I did ask the question of why. We've kind of danced around that this changes lives, it'll set you on a different path, all that kind of stuff. Is that real? Well, yeah, actually. For me, before I started this event, and I started a long time ago, in '97, with a very special car, only to be beaten by the '98 car that was a rolling coffin. It got me into engineering. I didn't know what I wanted to do in high school. Who thinks about that? Or you have some grand idea of where your life's going to be and what you're going to do, and it doesn't turn out to be like that. But where did this propel me? Well, it got me a mechanical engineering degree. I spent about 4 years working for NASA. I spent about 14 years working for Raytheon, a defense contractor, building things I can't talk about, and, well, more things for NASA that I can talk about. I've gotten to see 3, 4 launches now of things that I've had my hands on, that I've built, go up into space. I have the pride and feeling good about some of the work that I've done that keeps all of us safe. Again, things I can't elaborate on beyond that. I'm now with Northrop Grumman doing the same thing. I mean, most people don't think it's like a normal thing to go work for NASA, or can say, you know, I was a NASA engineer or am a NASA engineer. That's just not normal. But those are the kind of doors that this program opened up for me. The thing about you guys will, if you go through this program, you'll get in there in college, you'll be thinking about your final, the freaking final that you procrastinated on, and now, because you had too much stuff this semester that you loaded up, and it's like, crap, this sucks, this is tough. And then you'll think about, you know what, this isn't nearly as tough as it was to get through freaking scrutineering. Believe me, you will have that thought, I promise you that. So this is why we do it. You get a lot of different chances, you get a lot of different exposure. As somebody who's a hiring manager, I've hired probably about 40 or 50 people in my career. I will tell you, I absolutely look for outside experience. I get somebody who's got a 4.0 on their transcripts coming out of college, or a 3 point whatever, but they literally have done nothing. I will rank the person with a 2 point something that's got a lot of outside experience over that person with perfect grades. And you know why? Because they've actually done stuff like this that gave them the chance to fail and a chance to learn. That's what's most important to me, and I'm saying this as a senior manager. I left Raytheon as a director that hires people to do work in space. Just something for you guys to consider. I don't necessarily have a great spot to cram this stuff in, so yeah, I guess we'll pretend this is aerodynamics. With that, I just wanted to make sure you guys understand, one, don't worry about memorizing this, remembering it all right now. That's why we put it up on the web for you. Two, there's a lot of good stuff you can get out of this if you can survive it. And you do have to survive it because you will fail. Everybody in here will fail at some point in what you do. I failed a lot, but that's how we learn and we move past it. I guarantee you, you remember the failures you overcame a whole lot more than the things that were just a first pass success. Anyways, all right, enough ranting about that. Thank you guys for indulging me. Let's talk about aerodynamics, weight, and friction, coming from a person who doesn't really do a lot with aerodynamics, weight, and friction. Oh, well, I guess space stuff, there's a little bit of that. But look, let's be honest, credit where credit's due. I'm stealing these slides. Originally, they were done by Mark Westlake of the St. Thomas Academy. I've actually put his contact info in here because I know Mark just loves it when he gets random email surprises about this stuff. Actually, he's a really great guy for those of us that have met him. He is always happy to share and talk about their experiences. So I'm going to do some of that for you, and I'm going to share some of the tricks and thoughts as well as my personal thoughts on aerodynamics, weight, and optimization for your car. Take everything with a grain of salt. Everybody you talk to will have a different opinion about this. Oh, one more thing. Engineers. How many people know an engineer that is like an advisor or somebody that can help you with your project? Okay, good. Here's what I want to tell you. I'm saying this as an engineer, as a mechanical engineer that puts stuff in space. Question everything. If you have an engineer that tells you that the right way to do it is only this way, question why. Ask why. Get them to explain it to you and make sure it's something that makes sense. Lots of people, and this isn't everybody, this may not be the person that's involved with your group, think they know a lot more than they actually do about the specific thing you're trying to accomplish. They may not have had experience with high efficiency cars. They may think of some other concept that doesn't really apply, but just question that. There are people that know more, people that know less. It is your job as the team captains, the advisors, to be able to filter it. But if you can't understand it or you don't buy the rationale behind it, question it. That's all I'm trying to say. I've seen a lot of people come in who have been very confident and a little cocky talking to me about this, and they're like, no, I know how this works. I'm an engineer. It's like, well, I'm an engineer too. I don't think you're correct after seeing this for 25 years. Just be aware of that. I'm not trying to say everybody's going to give you bad advice, but even with what I'm saying here, this is meant as a primer and a little bit of my experiences and some remarks that I'm sharing on. Take it with a grain of salt. Okay, but there is cool stuff in here. All right, aerodynamics versus weight. We got to think about both these things. So if you're going to choose one thing to focus on, what's it going to be? Aerodynamics or weight? What matters more? Well, it depends on speed. It really does. It depends on what speed you're going to go, and it kind of depends on if you're going to be on the track versus the road. Well, what does that mean? Let's consider uphills and downhills. Heavier cars, when you're going cross-country, you're going to have to pull all that extra mass up a hill. On the track, you have uphills and you have downhills, but it all averages out to a flat surface. It basically negates itself. You can call it flat, even though coming out of turn 2, you're going to climb a little bit, and going into turns 3 and 4, you're going to drop a little bit, just because of the nature of the bowl of the speedway. But when you're on the road, you have mountains you're going to climb, you have hills, and you can find that out through topographical maps of the race route, or plenty of apps out there that'll give you that information now. Basically, the heavier your car is, the more rolling resistance. What is rolling resistance? It's a measure of how easy it is to push your car. Even if you had these super duper frictionless bearings that were super perfect, that was no energy loss, if you tried to push a 10,000 pound car up a hill, it would still be hard, versus trying to push a 10-pound car up a hill that's got crappy bearings with sand in them. So this is rolling resistance. There's lots of things you can do to optimize it, but weight plays a factor in that. Aerodynamics, on the other hand, play much more of a factor at speed. We're going to get into that in more detail on other slides. But let's talk about reliability while pursuing the ideal solar car, whether it's reducing weight, it's increasing the aerodynamics by changing the configuration of it. You can take this too far if you're trying to be as efficient as possible. The car that will win this race and the teams that will do the best in this race are the ones that continue to run. Those that think it's much more important that I shave that last 50 pounds off the car, so I'm going to hollow out the motor mount and I'm going to go super light on my suspension components, those are the ones that end up failing, 2 days, 3 days into the race, and it comes back and bites them because they ended up under-designing that part, all because they were trying to save a couple of extra pounds on something. So when in doubt, over-engineer it, because if you're looking for the best way to do well in this event, it's not to fail. It's not to have a mechanical or an electrical failure on your car, and just keep clicking the miles away. Never, ever, ever, and I can't emphasize this enough, trade weight for safety. If you have a question or you're worried about whether or not the area that's protecting the driver or something else, again, the thing that holds on the motor, or your setup for your suspension, your spindles for your wheels, this looks really wimpy, but it saves a few extra pounds, but maybe it's going to fold up while we're driving down the road. Don't do that. Overbuild it first. And this is why I keep emphasizing this point of testing and driving ahead of time, because that's how you find out in a safe space while you're back by your shop with all your tools and time to fix things that it was under-designed, versus in the middle of Carlsbad. So remember, it's a couple of things. You can take it a little bit too far, and be careful about not trying to save weight at the cost of safety. Just a cautionary note on this. So let's talk about aerodynamic drag. This is Mark's point, is that making a car more aerodynamic is the least expensive thing you can do to affect the performance of your car. And I'm going to say that I agree with him on this. A couple of things to point out. We talked about some of the shrink wrap coatings that you can get. That's all this is on the bottom of their car, sealing it up. Weighs next to nothing, closes it up so that you can move smoothly through the air. These fairings that they built, he's got in this presentation, I'm going to walk you through his trick on what he did, are actually super easy to manufacture and very cheap. They don't cost almost anything. You basically just need art supplies to do this. These make a big performance change on your car. So here's like a 2D slice of trying to look at what's happening to the air currents. Basically, when you see the color changing from green, you're causing eddies and you're causing pressure to build up. So when you do fluid dynamics simulations where you've got a model moving through here, and there's lots and lots of ways you can do it, including making your own little wind tunnel with a model with some fans, some straws, and a little bit of smoke, you can see what shapes work the best. So this is just one example of that. Some people will actually go and do some modeling on it. Do you have to do this? Not necessarily, but there are some guides you can look at. So these come out of some of the engineering textbooks that you can find. If you find a book on fluid dynamics, you can find all sorts of gold like this. Basically, drag always starts at the back of the vehicle, hence the name drag. And it's a result of the unstable air as it wraps around whatever object is there. So you can see with some of these shapes, you actually get a smooth, what they call laminar flow, which means the air basically stays in line instead of going crazy all over the place as I whack the microphone, like these little swirls back here. So this is called like laminar flow, so you can see the air smoothly directs around it. When the air stays in line like this, it doesn't eat a lot of energy. When the air starts spinning in circles, you have to spend energy to make each one of these circles, which is why you have drag, or what that drag is. That's all the extra energy because this is all turbulent and you're disturbing all of the flow of the air. And so here we can see a couple different examples of shapes, and I'm not going to go into more specific details on this, but you want to choose shapes if you're talking about optimizing it and you're thinking about the overall design of your car that will let the air release smoothly behind it without creating these vortices, eddies, and turbulent air behind it. Fairings are, again, there's an example we're going to show in here that are a very simple way that you can reduce some of the drag on your car. More examples of shapes. Here you go with another set of things where you can look at the different shapes and the drag coefficient. The higher the number of this, the more drag that shape has. So just something to take away. Again, you can go into like a fluid dynamics textbook, a mechanical engineering handbook, and you can find examples of this. Heck, sorry, let me get with the digital age. You can Google most of this. But this gives you an idea relative to things. It's like, well, if I just stick a giant cube in an airstream, I'm not that efficient. If I get some sort of streamlined, they call it a half body or a streamlined body like this kind of elongated teardrop shape, it's like, what, 5% the drag of sticking a cube plow in the air? So that's why you see so many solar cars with these kind of shapes. That's your takeaway. It's meant as a rough guide. Let's do a quick comparison of some drag. Let's look at an upright bike, random picture I stole from the internet, versus the velomobile. So this is a human-powered vehicle that's meant to be super efficient, and this is like, I want to go ride and by the beach and enjoy my afternoon. Well, I'm in a full upright position. Some actual numbers from that. Let's take a look at it. This yellow line right here is the total amount of drag, how much it's pulling you back, or how much extra work you're having to do based on the speed you're going, just being upright in the air, versus this green line where it's the velomobile. And notice that in the very beginning, at very low speeds, there's no difference. There's not a lot of air that you're having to move. But as we move on, let's like pick 15 miles an hour, we can start to see a little bit of a difference here, where you end up with about 125 watts of drag for being just upright out there in the air, but when you try and optimize, you're at like 50. That's basically free energy that you're losing. All of this matters when you only get enough power to run a toaster off of your solar array. And by the way, even those really efficient solar arrays, they're enough to run one of those like 4-slot toasters, if you ever look at them. I never realized how much power it takes to run a toaster, but there's my example for you. But here, just being upright in the air, you're losing a ton of energy. So just by being a little bit more smarter about the shapes, you can save stuff. And that's only at 15 miles an hour. What happens if we just go 5 miles an hour faster? Well, let's put the line there. Now look at the difference. I'm at about 90 watts of drag with an efficient shape, and with an inefficient shape, I should say, I'm at like 270 watts. So I'm at 2.5, almost 3 times the drag just for not thinking about aerodynamics. And this is only ranging between 15 and 20. Anybody know the minimum speed on the track? Yeah. So does this matter? Yeah, it matters some. Does this matter more than making a car that'll actually survive running on the track? No, it doesn't. Because if you spend 2/3 of the race in the pits working on your car, your super efficient aerodynamic car, the person that built the airplow square car that just stayed out there making slow laps, yeah, they're going to beat you. But if you're talking about optimization, yeah, let's do a little bit with the car. How does aerodynamic drag work? Well, here's the formula for those of you that are interested in math. The takeaway, though, is it goes with, and Shannon was mentioning this, it goes with velocity squared. So if you double your speed, you get 4 times the force, no matter what. You're holding everything else constant. So things to think about there. Let's talk about these wheel fairings. You guys saw the really cool slick thing that St. Thomas did on their car, where they have these nice wheel fairings. Well, this is all that they got. They went down to like Office Depot or Staples, got some foam core board, grabbed some razor blades and hot glue. Those 3 things at the top are all you need to start this process. You can then get a little bit of carbon fiber, which I have less experience with, but fiberglass I've done a fair amount of. You need some epoxy resin, as Mark always says, a little bit of creativity, and body filler. Automotive body filler, you probably want to find something light. You can use something like Bondo, but lighter is better for this. Here's what they did. They basically took that foam core board, and it's a little bit hard to see in this photo. You can see it over here better. They took the razor blade on one side and made a bunch of vertical slits on it. That allowed them to basically bend the board into the shape that they wanted, and they hot glued it. All of a sudden, you now have the start of a mold for a fairing. And all you've done so far is take a $10 piece of foam board from Staples and some hot glue and make some slits in it. And then they bent it to shape and glued it together. That's the start of it. If you get it wrong, you've wasted like no money and just a little bit of time fooling around with this. After you've got the shape that you want, all you need to do is add 1 or 2 layers of, pick your favorite, carbon fiber or fiberglass on top of it just to make it a little bit more rigid. And that's what they're doing here. All they're doing is laying the glass cloth on top of it and painting it with the epoxy resin. And a note is that the epoxy resin will not eat the foam core in these boards. Again, these cheap, like $10 presentation boards you can get from an office supply store. Mark also has a little bit more information, and I invite you to go back to when he gave this presentation where he can talk about some of the tricks, like how you can squeegee out the excess resin from the fabric. Because again, your goal is to keep it light. The resin weighs a lot, and you just need a little bit of material on the outside to make it a little bit more rigid for you. What they did next is they turned these things around and they basically glued in some additional fiberglass support to make a little mounting bracket attachment plate to it. That's the only takeaway from this. And again, this is where the creativity comes into play too, because you want some way to mount it to the rest of your car. So they basically created brackets and tabs when they folded it over in here. And then once it was dry, they basically trimmed this excess out. Because you can see they took another piece of the foam board and stuck it on top, and then put they used carbon fiber, but you can use fiberglass, over it to make it rigid, and then they just took a jigsaw and cut out the opening in there so that you could stick the wheel through it, but then you were left with the edge that you can use for a mounting surface. And this is the final product. That's how they got to these. I'm going to give you another example that I thought was a little bit cooler. This is their super mileage car. Note the same thing that they're doing here. This is more of that foam core board that they're just cutting horizontal lines in so they can bend it to shape, and taking an X-Acto knife and cutting out holes where they need to for components to be in there. And hot glue. Anybody can do this. They went back and it's like, okay, we've got the center part of the body on there, let's start working on the fenders. Same exact concept, hot glue and foam board. And they're getting this rough mold out here to be their highly aerodynamic body. Again, continuing on through the back. This is literally for, and this school, St. Thomas Academy, does exceptionally well in these events with these high mileage, high efficiency cars. This is all they do to build it. Anybody can go build a body like this. You're talking about maybe $50 to $100 worth of material and some time with some hot glue and some razor blades. I mean, anybody can go do this. Same concept though, a little bit of fiberglass on top of it, afterwards, a little bit of body filler, and what they went and did is they got vinyl decals to put on top of it. So here's them actually putting the vinyl wrap on there just to decorate it. Actually, I'm not even sure they did the fiberglass on this to make it even more rigid. I think they just kept it lighter and literally covered it up with vinyl decals. This was the end result. So this is one of the easy cheats, and this is why Mark is saying that It's very inexpensive if you want to make your car more aerodynamic. We also talked about the shrink wrap that you can use on the bottom side of your car that'll just pull to things, and you can get it with a heat gun. So there are some things out there that make it very easy if you want to increase the aerodynamics of the car. So click back to this real quick. So you're on this green line on the bottom and not this yellow line up at top, just wasting energy on the track, plowing through the wind. So just stuff to think about. I know that a lot of teams out there that are really advanced are making their own plugs and their own molds, and they're doing full carbon fiber composite, monocoque chassis, things like that. For a first-year team, don't worry about all that. You don't have to do that yet. But if you want to do some cool tricks that can lead you to a car, literally this car, which did exceptionally well, all they did for the aerodynamics was the shrink wrap and some foam board work. Admittedly, they did a little bit more on the top of the car, and I think I left the picture out of order for that. Yeah, here you go. Here's where they went back after they glassed them, and they put a little bit of Bondo or body filler. I'm not sure which lighter body filler there are out there. I'm used to using Bondo. They primed it, and they had a really good painter that, as Mark says, good painters hide a lot of flaws. So you get this car that, just looks amazing out there on the track. Again, it's a bunch of foam board from an office supply store. So that's aerodynamics. Let's talk about weight for a second. Again, I explained to you that when we talk about rolling resistance, and there's a number of factors that influence it, but none more than weight. Rolling resistance is simply how hard it is to make your car move forward on a level surface. If you were to take your car out to a parking lot and get one of those like fishing scales where you can weigh a fish, hook it up to the front of the car and pull it, you can measure the rolling resistance. And honestly, that's something you can do if you want to see an improvement that you're making if it actually affects things, like lubricating bearings or changing the type of wheel and tire that you've got. Or, you know what? Let's put 50 pounds of sandbags in the car and let's see how much that changes the rolling resistance. If you're curious, you can see it right then and there. Just all it takes is a flat surface and a scale, maybe some ropes tied to the front of your car. Heavier cars always need more energy to accelerate. You have to pick it up and carry it with you every time you move up a hill. But again, I already said this in the beginning, do not reduce weight at the cost of safety. And I put this in red, bold, and underlined it. Things will break. If you make things too light, they will break. And that will ensure that you are not successful at this event. I cannot stress this enough. When in doubt, early on, and if you're not going to have a lot of time left for testing, overbuild a little bit. It will do you a favor when you come to the event because your car will just be able to stay out there on the track, even though it may not be as efficient as it could possibly be. Some other things that affect rolling resistance. Most bearings can be opened up. Usually they have a cover on the side of them or they're exposed anyways. You can rinse them out with a solvent, make sure you've got no dirt or grit in there. If they're packed with a heavy grease, you can replace it with a light oil. On a side note, if you're going to weld on a spindle with a wheel in place or a hub, make sure you actually remove it because if you heat up your really expensive bearings to welding temperatures and then cool them off with a squirt bottle, they instantly rust. Don't ask me how I know that. But yeah, you can, again, bearings are an easy place. Just replace them with light oil. You can look at different tires. Motorcycle tires, lots of first-year teams use motorcycle components. We use motorcycle components. They're reliable, and they give you good handling control, stopping power, and everything else. Do they have more rolling resistance? Yes, but we've had plenty of things where people with the ultra-skinny moped tires or the high-end tires made for solar car racing end up with a minor alignment issues and start blowing them out on the hot track. And the team with the motorcycle wheels just didn't care. Tire pressure, that does matter when you care about rolling resistance. You do want to get it close to the rated maximum or at the rated maximum. And remember, that's going to go up when it gets hot. If it rotates, lubricate the thing, otherwise you're wasting energy. And this last one, wheel alignment. If your wheels, as you're going down the road, are pointed like this, you're going to have a lot of freaking rolling resistance. And all that takes, in the most simplest form, is 2 tape measures and 2 people looking at it to get them from being like this to being parallel. There are better ways you can do it than 2 tape measures, but if you wanted an early approach, and I know a lot of teams out here have experience with other cars and racing, that's something that there really isn't that much excuse for wheel alignment being off, because everybody can check that and fix that. Unless you designed yourself into a corner and made it so there's no way to actually align your wheels, in which case, well, I can't really help you. That's it. That's what I've got on my rants, weight, and aerodynamics.